Yes, ma'am. Visible.
Okay, so you can see, right? This is a 3D orientation where you can actually, on the right side, if you will see, you can actually apply this. You can see that how it is rotating, C5 rotation. Now, if you have an inverse rotation, this is also been seen. How sigma plane is there. You can see the rotations, right? So all
Yes,
the
ma'am.
elements and the operations you can actually find in this particular website, which will help you to analyze the molecule even more properly. Because for me to define in a 2D image, that is very difficult. So I can only just make you understand with that. But these kind of systems on this website, you can easily find out all the symmetry elements. So I would recommend you guys to go to this website, Symmetry Autopilot. It is not having any login issue or something like that. It's free of cost. There would be a gallery. You just go and see how the molecules and what kind of symmetry elements are there. That would help you to gain more confidence in finding out the point groups, because analyzing each and every molecule and point group, it's little difficult. So as we already got to know that it is having 5 C2s perpendicular to C5, now we need to see whether it is having a sigma H. Sigma H is something which is a molecular plane perpendicular to your iron. So if you consider this, my hand is as a 1 CP ring. This 1 CP ring is there, that is one. Another one would also be like this way, like as a sandwich form, because it is an eclipse. And in between, this is my, in between it would be having an iron. And if my axis was going along the iron, this would giving a rotation C5 we were seeing. But now the plane has to be perpendicular to my axis. So this is my axis. This was my axis. Now the plane has to be perpendicular. So the plane would be perpendicular to the axis, but it would be cutting my one half. Like it would go through the molecule. It would bisect the iron into two halves, two equal halves, but it would reflect one ring over the other. So therefore, sigma H is there. Is it clear?
Yes, ma'am.
So if sigma H is there, so the point becomes very straightforward. You saw that C5 is there, you saw 5 C2s are there, and sigma H is there. So the point group easily becomes as D5H. You do not have to go further and to find out how what other symmetry elements are there or not. For any D5D or D5H, you just have to multiply with this number 4. So you will get a 20 symmetry elements. So for example, if you have C and V, C and H or something like that, this has to be multiplied with N into 2. You can cross check. This is a mathematical calculation. You can just cross check and you will get the exact number. So for D5H, it would be 5 into 4, that is 20 symmetry elements are present. If I'll talk about D3H, it would be 3 into 4, that is 12 symmetry elements. These kind of things are good to answer the questions when you are in a competitive examination or something like that, where you are short of time. But this will come only after the practice. There could be a possibility that they are going to ask what kind of symmetry elements are present in that particular molecule. So for that matter, you should understand. So we have to go through linear, cubic, all these matter, and we need to know okay, what other elements could be present in the D5H group. Is that clear?
Yes, ma'am.
Okay. So we are taking the second question. So this question says that consider a non-linear molecule with identity, which is having one C2, the two C2s which are perpendicular to this earlier C2. So this is perpendicular to this one, this C2. We have sigma D, we have S4. Now they are asking which point group it belongs to. So firstly, we saw that CN is there, and also perpendicular C2s are there. So will it belong to CN or it will belong to DN?
DN.
Right. You have to be very confident because it's very clear. You check that, okay, principal axis of rotation is there. And also corresponding to that, more C2s are there, which are perpendicular to it. So this is the definition of dihedral point group. So DN is for sure. So these two options, anyway, they got eliminated, right? So it becomes your job
Okay,
very easy. Just looking at the elements, you have eliminated 50% options of your system. So that makes your job more easy. Now having a comparison between D2D or D2H, just look at the elements. What do you think? What would be the answer?
D2D.
Right. Because it is having sigma d, it is not having sigma h. The option answer is option C. Is it clear?
Yes, ma'am.
Okay. Now, the third question, which of the following belongs to cubic groups? So you need to find out, we have already seen linear groups, we have seen the dihedral groups, we have seen single axis groups, we have seen the cubic groups. Among the four options, which belong to the cubic groups?
Ma'am, both the tetrahedral and octahedral comes under
It could be
cubic
more than
groups.
one option correct. So A and C, they both are right because they belong to cubic group as they are having maximum number of symmetry elements. Okay.
Okay, ma'am.
Next question is, find the geometry and symmetry of CLF3 molecule. Symmetry elements. So CLF3, this molecule, you first define its geometry. So how do we get the geometry? We know the Weissenberg theory, right? Valence shell electron pair repulsion theory. So chlorine is having how many unpaired electrons? Valence shell. It's having a 17 atomic number, 7 unpaired electrons, right?
Yes,
Fluorine is also, fluorine is having 9 electrons, but unpaired is only having 1. So fluorine can give only 1 electron to chlorine. Is it right? So when
yes.
we are having, like if I'll draw this chlorine ka configuration, just to make you understand, neon is 10, and after that this is 3s2 and pp5, and this would be your 3d, right? So it is having unpaired electrons like this way. If I am having this Cl as 7 and 1 electron is coming from my fluorine negative, so total are 3 F negatives, that means 3 electrons, which it is binding or donating to the Cl. So 7 plus 3 becomes 10 electrons. So since we have 3 fluorines, so chlorine can only bind with 3 fluorines. So one bond will require 2 electrons. So out of the 10 electrons, 6 electrons will go in bonding pairs. Is it right? Like, so we have 7 electrons which would be participating in hybridization of chlorine of 7 electrons. 1 electron is coming from F negative each. So total becomes your 10 electrons, right? Now we need to assign these 10 electrons into bond pairs and lone pairs. So one lone pair comprised of 2 electrons. One bond pair also comprised of 2 electrons. So since if I'll say chlorine is making 3 bonds because we have 3 fluorine atoms, 2 electrons, 2 electrons, 2 electrons. How many has been used? 6 electrons. That is for bonding electrons, 6 already has been used. Now 10 minus 6, 4 are left. This would be used in lone pair. Is it right?
Yes, ma'am.
So if one lone pair is comprising of 2 electrons, so 2 lone pairs would be having 4. So therefore, these 4 electrons will go to 2 lone pairs. So then geometry of your chlorine will become like, according to lone pair, bond pair repulsion, it would be like, sorry, because of the repulsion factor, we need to make it chlorine, because the hybridization of this CLF3 would be sp3d. These orbitals would be in one. So the lone pair would try to be in the equatorial position because of the repulsion. So this is the kind of shape. So this is the geometry that we are having. So this is something called T shape, right? Where the lone pairs are in the equatorial and that is. So now we know the shape of it. Now, depending on the shape, we can call it of a symmetry. So we need to find out whether it is linear,
No.
cubic.
No, ma'am.
Yeah. So is Cn present?
Yes, ma'am. Present.
Which one?
C2.
Why not C3?
C3. Because 120-degree rotation not possible here.
Yeah, because these are at actual position which are having a 180-degree angle difference, and this is not a shape which is the pyramidal. So they are not forming any proper triangle where all the 120-degree rotations will be possible. So C2 is possible. Now, how many C2s are possible? And C2, firstly, from where the C2 is coming, which axis, involving which atoms? C2 means it can only have two fluorine atoms on the left and right side. So that means the C2 must be passing with one fluorine containing the chlorine. Like for example, one C2 would be like this way, and it is reflecting or it is rotating one fluorine the other one. Is it right?
Yes, ma'am.
So this C2 is there corresponding to this C2. If this is Z direction, we have C2s here also, which is passing through this one. Sorry, this is only having one C2. This can't be having other C2. This is also very valid point. If I'm having one C2 here, if I'll just go draw the one C2 which is passing through Cl and F and F2, this C2 is not possible because this fluorine is having no fluorine other side to have a rotation. Is it right?
Ma'am, but if we rotate 180-degree, that fluorine atom goes that side.
Yeah, that fluorine will come. So that can't be called as an equivalent conformation. It should come in the same conformation that we have drawn. If you are starting with this one.
Okay,
It should
ma'am.
be having. If it is having fluorine like this way, then there is no change. But one position has gone to other position. Earlier there was no fluorine. Now it is having. That is not at all an equivalent conformation, right?
Okay, ma'am. Okay, ma'am.
So no C2s are there. So one C2 is there. So no perpendicular C2s are there. So what we need, that means it's a single axis rotation group. So in that we can have CNH, CNV, CN also. So we need to find out which sigma is present. So is there any sigma present? So in that case, when you have defined your axis of rotation, say for example, this C2 along this direction. So if you have defined it, first try to put plane on the same parallel to it. So if my Z direction like this say this is Z direction and this is my C2. And if this where I'm putting a plane, I'm just cutting. So the above F would reflected by the other one. Is it right?
Yes, ma'am.
Right. Similarly, if one sigma v is there, that would, if it is parallel to your axis, this is having z axis and this is only plane, which is being called as, if this is my z axis, this is x and this is y. And if I'm saying along the z axis, I have given a yz plane. Y is coming like thumb. It is out of the plane. If it is cutting and it is reflecting my f and f. So if yz is there, which is parallel to your C2, that is called as a sigma v. If one sigma v is there, second sigma v will also be there. So there would be two sigma v's. So one C2, two sigma v. This gives you C2. Is it right?
Yes, ma'am.
Okay, great. Now the fourth question that we have is find out the correct statements about chirality. You need to find out the correct statements about the chirality below. So first point is superimposable mirror images. Does chirality say that the mirror images have to be superimposable or non-superimposable?
Non-superimposable.
So this option is right, this is wrong. It should have a centrosymmetry. Centrosymmetric is something it should be having a I. Should it have I, inversion center?
No.
No. If it is having an inversion center, that can't be a chiral. So the last point, molecule, the point group CN or DN, are they called as chiral?
Yes, ma'am.
So these statements are right. Now the 3 questions are more left, 6, 7, and 8. I will keep that as a homework. You guys go and try that on your own. These are also straightforward and that I've already explained somewhere, because this chiral molecule I've explained, taking that example of cobalt, you need to find out and draw the enantiomers. This is find out whether H2O2 is chiral or not. You have to use the same concept, and you need to find out what is the how many number of C2 axes are present in the CCl4. So this is a case of tetrahedral. So I have already explained the tetrahedral. You need to find out the answers for these questions, and these we will discuss in the next live session. So up to what we have studied, we covered the point groups. We covered like how to define a point group, how to get to know whether it is coming to this point group, that too with a systematic manner. We need to define whether it is linear, cubic, CN, or something like that. You can reach up to certain point group. Then we find out the symmetry elements also. We also discussed about the chirality, enantiomers of the chirality, and we have discussed the tetrahedral. The octahedral symmetry elements we will take up in the next live session. We have to cover the week 3 assignment problems also, and these 3 questions, that is a homework for all of you. So you have to solve it. If there is any problem, we can discuss it in the next live session. And you can go back and watch the first live session video also. It is already uploaded in the YouTube video. I've given the link in this particular presentation slide. These will also be shared in the folder. So you can go back and read and cross-check your question and answers, and you can come up with your doubt. So despite of that, whatever we have read in the whole session, is there any doubt you are having? Like anywhere I need to explain again, or if you have any question in your mind, you can just ask me.
No, ma'am, for next class, I need to take any basic things. I need to learn any basic things.
Basic things is just you follow, you are enrolled to this course, you just have to watch the videos that have been uploaded by the professor. Professor Ranapratha has beautifully explained all the concepts in details in 5 videos. There would be 5 videos in week 1. So I would recommend, before this live session is all about your doubts. And if you have already watched the live, those videos of the professor, you have made your notes, you have tried on your own, then only you are able to ask me the questions directly, right? So just go through those videos. Also watch the videos for week 3 that would be uploaded. And same time, 7 to 9 p.m., we will be having a live session next Saturday. You can come up with your questions, whatever you are having. And I will be giving the assignment problems, and we will be having a similar discussion pattern like we are having today.
Okay, ma'am.
Okay. So besides that, is there anything you want me to clarify on the whatever the topic that I have told or taught today?
No, ma'am, clear.
Okay. So even if there's a big platform, you can still come and ask for any question, any point of time, like on Saturday itself, 7 to 9 is the time. And I've already given the link of this YouTube channel where I've uploaded the live session 1 ka video that has also covered a lot of basic concepts. You can go back and check in full details, like what is CN, what is SN, what is I, or something like that. There are many examples in assignment problems. And also make sure when you're attending the next live session, you watch the week 3 videos of the professor. Once you are acquainted with what kind of topics he has read and try to solve the assignments, then it would be very beneficial for you to understand the concepts even more better. Right? So with that, if there is no question, I would end up this meeting. And it was nice having you in this live session. Hope you have enjoyed the lecture. Thank you.
Thank you, ma'am.